Welcome to Standex Electronics presentation on the liquid level sensing technology. We will present and define the liquid level sensing technology. We will also present the key functions and define all critical terms. Along with this, we will investigate the various package configurations and review the various expanding applications. There are typically three liquid level sensing approaches. One approach uses inductance to sense motion. The second uses a direct connection from a float that mechanically moves a contact switch. And the third approach uses a float with an embedded magnet that activates a reed switch. The inductive approach is expensive and requires a lot of circuitry. The mechanical approach can easily get clogged and is subject to failure in dirty environments. For these reasons, we will focus on the reed sensor technology, which is winning over most applications. Defining a liquid level reed sensor is quite simple. They simply have a float that rises and falls with the given level of a liquid. The float can only float up and down in a controlled vertical manner. When the float reaches the detection point, whether it was rising or falling, it will activate a reed switch that is in proximity to the float. When the float moves away from the reed switch, the contacts will open. Liquid level reed sensors are fast becoming the level sensing technology of the future. What is driving this is its key reed sensor characteristics. They draw zero voltage and current, no power until they are energized. They can sit for years never drawing any power. This attribute alone allows them to be designed in many applications where power is scarce. This includes many battery-driven applications. The key component in the level sensor is the reed switch. The reed switch is hermetically sealed. This means it's impervious to any outside environments. This includes all operating temperature range from -40 Celsius to 200 degrees Celsius, along with wet, moist, dirty backgrounds. The switches are then further sealed in rugged plastic with epoxy seals. Stainless steel packaging is also an option. The reed switch is operated by a magnet coming within a certain distance to the reed switch. The magnets are embedded in the float. As the float moves over the reed switch, it will activate and close the contacts. This remote sensing keeps the sensing circuitry away from any potentially strong liquids that could influence its operation. In its hermetically sealed, the contacts can switch in the millions of operations for long life applications. The reed sensor level, in its simplest form, is composed of a magnet and a reed switch or reed sensor. Generally, the magnet is mounted to some type of float mechanism. When the movement of the magnet comes close to the reed switch or reed sensor, the contact will close. When the magnet is moved away, the contacts will open. Most of the time, the reed level sensors have many more added features, which we will focus on hereafter. The ability to measure the level of all types of liquids efficiently and accurately requires highly reliable components. These liquid level measurements generally use a liquid level sensor consisting of a stem and a float. The float is usually cylindrical with a hole in its center. The hole in the float allows it to ride up and down the stem of the sensor. The stem is usually plastic and houses the reed switch within it. The stem has boundary points which defines the float's end movement. The upper end of the stem usually has a plastic build-out where the electrical connections of the reed switch exit an epoxy seal. The end of these wires may have connections or free wires to directly solder to external electrical circuits. A singular normally open reed switch is the simplest switching configuration and most used. However, the reed sensors can be configured as normally closed, latching, single pole, double throw, and multiple single pole configurations. In many applications, the stem and float are immersed in the liquid being sensed. It's important to match the stem and float for a given liquid. Polypropylene is typically used for water and mild acids. Polyamide is generally used for oil, gasoline, and brake fluid. Nitrobutadiene rubber is usually just referred to as NBR and is primarily used for the float material. The NBR offers much better resistance to oil, fuel, and the ability to operate reliably in high-temperature applications. NBR has excellent features over a broad range, including an excellent stable buoyancy ranging from -55 Celsius to 180 degrees Celsius. The liquid level reed sensor features an all-inclusive design that has the magnet-embedded float and a PCB mounted within the stem housing of the reed switch and electronic circuitry. The stems can be as long as 250 millimeters for a plastic LSO4 series and 2,000 millimeters long for our stainless steel LOS5 series. They also feature the ability to work with either hot or cold liquids, having multiple sensing points and floats. The switches are dynamically tested for reliable switching. Many liquid level sensing applications can call for multiple detection points. This is an ideal application for the liquid level reed sensor. Here, all the circuitry is mounted on a PCB that is mounted internal to the stem. Typically, a resistor is used in parallel with each sensing point. In this case, as the various reed switches are energized and the overall resistance changes, this information is digested by a computer that converts this change in resistance to the latest level, which then sends this information to a readout mechanism or to the end user. There are several laboratory fluid systems that use reed switches to monitor their fluid levels that help control very elaborate equipment processes. These new float sensors have 4 sensing positions, 3 of which are dedicated to monitoring hot fluid levels, and the 4th senses a low fluid level cutoff point. This 4th sensing point is for safety reasons that sounds an alarm if the heating coils are ever exposed above the fluid level. This could cause the coils to overheat, causing a potential fire. Liquid systems all have their own specialty aspects and their own peculiarities. The liquids vary in density and viscosity, and going from water with a centipose of 1 to liquid epoxies having up to 10,000 centipoise. Also, some liquid environments, flour inert 3M liquids for example, can have very wide temperature ranges that vary from -40 Celsius to 200 degrees Celsius. Also, water under high pressure can become superheated. Meeting these extremes is no easy matter. However, the reed switch level sensors get the job done. The reed switch activated level sensor is the ideal technology for monitoring automotive fluid levels where the sensor has to work over a wide temperature range and in very dirty environments. That is why they are selected for monitoring fuel levels, engine oil, ABS, automatic braking system, power steering, radiator fluid, window washer level, etc. When it comes to aerospace requirements, only the most reliable proven components are chosen. Designers of level sensor requirements generally select the hermetically sealed reed switch for their fault-free sensing operations in the fuel tank, oil levels, etc. Also, the marine industry chooses the reed-based level sensors for their fuel levels, oil levels, liquid propane gas, and bilge pump water detection and pumping. There are a wide variety of industrial requirements for reed switch controlled level sensors that are currently either using or being designed into the following: oil level gauges for transformers, air leak valve in underwater applications, boiler control, auto drain for pneumatic filtering, lubricating units, generators, gas pump fuel dispensers, underground gasoline tanks, etc. There is a serious amount of equipment that uses reed switch activated level sensors in the home and the office. Some of these level sensors are found in humidifiers that monitor the level of their moisture intake, various types of cleaning equipment that uses water, detection of the liquid level for 2 different kinds of gravity liquids, example oil and water, rug washing equipment, hot tubs, and the detection of water levels in the equipment that uses water for cooling. Many of our home appliances use the reed-driven level sensors in solar systems, saunas, dishwashers, air conditioners, and showers and toilets using electrical pumping systems, etc. Each technology has its own best operating characteristics. New design-in for liquid level detection continues to increasingly select the liquid level reed sensor. This is because of its favorable characteristics and versatile design capabilities over other technologies.